Hello, everyone. Good afternoon, and welcome. Thanks for joining us today. I'm Ryan Jones. I am the Interim Executive Officer of the Penn State Alumni Association, and I want to welcome you all to today's virtual speaker session, which focuses on scientific research impacting students and society with examples from Penn State's College of Earth and Mineral Sciences. Before we get going here, I want to just share that there are live closed captions available. You can access them by clicking the closed caption button at the bottom of the Zoom video window and then clicking Show Subtitle. You can also customize your caption view by clicking on the stream text link posted in the chat. And we're also live streaming today's presentation, which will be archived and available on our website. Turning our attention to today's topic, the College of Earth and Mineral Sciences traces its origins, at Penn State back 130 years, born of an interdisciplinary approach to supporting workforce development for the extractive industries. This afternoon, you'll learn how the College of EMS continues to take that same interdisciplinary focus. In every example, students are working side by side with world-class faculty, advancing their education while making a difference in the world. Today's guest, Lee Kump, has served as the John Leone Dean of the Penn State College of Earth and Mineral Sciences since 2017 and has been on the Penn State faculty since 1986. He's an elected member of the National Academy of Sciences and a fellow of several professional societies. In March, he announced that he will be stepping down from this role effective at the end of this month to rededicate his efforts as a professor of geosciences in the college. Before we begin, I want to take a moment to thank Dean Kump for everything he's done for Penn State. More information on his legacy and his impact at Penn State is available in the chat area. Lee, thank you so much for joining us.
Well, thank you so much for having me, Ryan, and thank you all for joining us here today. Hope you're having a good day, and thanks for spending what is more or less your lunch hour with me today. I really appreciate the opportunity to talk about this wonderful small college of ours, College of Earth and Mineral Sciences. As Ryan said, we have a long history at Penn State, born of our support for the mining industries, and then oil and gas development. But from the very beginning, it's been an interdisciplinary approach. And in our most recent structuring, really starting with Dean Steidel nearly a century ago now, we focused not just on the engineering aspects or the scientific aspects of the mining process, but rather taking a more holistic approach to that endeavor, thinking about the maps that need to be made and the weather and how that impacts things and the raw materials and the produced materials. So we've always taken this thematic approach to our work. So really focusing less on the disciplinary areas that we represent and emphasizing those areas where our disciplines can come together to solve important problems. We have a bit of an identity problem, frankly, College of Earth and Mineral Sciences, and are considered a discovery college, and our majors are largely discovery majors. And so we've been thinking about how to best get the word out about us. And like IBM or 3M, maybe the EMS acronym is a good way to start. And this word cloud here is meant to represent some of those E's and M's and S's that EMS really represents. So we do have academic departments, and there are 5 of them. We have energy and mineral engineering department, geography, geosciences, material sciences and engineering, and meteorology and atmospheric sciences. And in those 5 departments, we have natural scientists, physical scientists, we have engineers, and we have a good cohort, especially in the geography department, but also in energy and mineral engineering, of social scientists focusing on human dimensions of the work we do, and energy and in the energy business and finance area. We also have long-standing interdisciplinary institutes. In fact, our interdisciplinary research institutes were the first at Penn State, and were the progenitors of that extensive network of interdisciplinary research institutes that Penn State now supports. We have one of the first formed groups supporting online education, the John Dutton Institute for Teaching and Learning Excellence. We have the Earth and Environmental Systems Institute and the EMS Energy Institute. We also have some of the top ranked programs at Penn State, as you see here in our rankings, U.S. News and World Report, rankings of undergraduate and graduate programs. Each of our departments and their programs is represented in top 10 or top 20 rankings here as we are internationally as well. And so really high QS World rankings. So really successful um, uh, programs here. We've attracted great faculty, built a strong cohort of students. They're all very successful, and we really consider ourselves a center of excellence at Penn State. So to, better understand challenges facing society, we take a variety of approaches, one of which is to dig into Earth's past. Our motto is that there are lessons from the past that can best inform Earth's future and decision making about that future. And in this case, that digging into deep time is a bit more shallow here. Sarah Ivory has been exploring how the landscape for early human evolution, particularly in East Africa, was impacted by fire and other aspects of climate change. But we also take dives into Earth's future. We look to Earth's future, and here's just an example of a group of students and their faculty mentor who won a national challenge around building a more efficient solar panel. So, one of the big challenges to society going forward is decarbonization, the reduction of greenhouse gas emissions that are associated with human activity. And one of our most exciting developments in that area is an invention that we're calling LionGlass. It's a new glass not made from typical glass ingredients and contain carbon, the soda lime silicates, but one that is carbon free. It also melts at a much lower temperature, so it takes less energy to produce it, and it's a more resilient glass than is the standard soda lime silicate glass formula. The inventor of this glass is John Morrow. John came to us from Corning several years ago. He's serving as the head of the Department of Material Sciences and Engineering, and he will be my successor come July 1 as the interim dean of the College of Earth and Mineral Sciences. He came to Penn State because he wanted to take his research and his ingenuity and engage with students to bring them into the fold. And so here is a picture with a team of students, postdocs, research faculty, and some of the sponsors of LionGlass that have been developed. And in fact, one of the holders of an early LionGlass patent is a former undergraduate and then graduate student at Penn State. So student engagement in what we do is an important part of our mission and of Penn State more broadly. We're working diligently to use LionGlass as a good example of how we can get our inventions, our intellectual property to market quickly through commercialization. We're partnering early on in this process with several companies, and we really think this is going to be a huge breakthrough and a huge thing for Penn State. We like to think of this LionGlass as the Gatorade for Penn State. So keep your eyes out for LionGlass as we continue to develop this formula. We've been working with specialty glass companies for perfume, small, high quality bottles. But now we're looking at the flat glass, the plate glass, window glass industry because we think LionGlass could replace much of that flat glass industry going forward as well. So, you might ask, why decarbonize? Well, there are a number of reasons, and many that EMS faculty and students are investigating. One of those is sea level rise driven by ocean warming and ice sheet melting. And in that regard, we're a world recognized leader in research on ice sheet stability. We're focusing on active ice streams and glaciers in Antarctica and Greenland, looking at their current status, and their vulnerability to catastrophic collapse. But as we've seen earlier, we're also experts in other climate change-driven factors as well, and that includes wildfire. Um, and we have experts in geography, meteorology, and atmospheric sciences and geosciences who are studying various aspects of wildfire in modern environments and how they impact society, but also in ancient environments as well. So lots of focus on climate change related aspects, but that's not all that we do. And in fact, we pride ourselves in taking a very balanced approach to the issues that are arising as a result of human activity, and in this case, greenhouse gas emissions. We, for example, have, as I mentioned, we've very strong petroleum and mining engineering programs and faculty, and sort of uniquely have this expertise in the same small college as some of the world's leading climate experts. And so we, for a long time, have strived to work collaboratively toward solutions and ones in which we keep an open mind about the future and the best path forward, recognizing that there are always going to be trade-offs between growing prosperity, in this case, energy for society, for the future, and the environmental impacts that are associated with those. Here's a short video that I thought we could show that describes some of that work. It's a collaboration between two faculty and their students in our energy, business, and finance program who are looking how best to achieve a significant reduction in carbon emissions by 2050, while recognizing that there are trade-offs between achieving that goal and economic prosperity. How do we choose the right mix of energy sources for the future, while achieving that goal of carbon emissions reduction, but also maximizing prosperity? Let's take a watch.
Look around. Wildfires, droughts, floods, and other severe weather events are increasing. They're intensified by human-caused climate change, making the goal to cut greenhouse gas emissions of 80% by 2050 more and more urgent. Decarbonizing the power grid is central to meeting that goal. Most fixes call for a swift transition to a low-carbon electric power system employing renewable technology. But researchers at Penn State say it's not that simple. Embracing technologies today in the face of uncertainties tomorrow could lead to less stable energy supply that costs more and limits our response to climate change. Penn State researchers Mort Webster and Seth Blumsack say there's a better way.
We need to make the grid lower carbon, but we should not be locking in now how we will achieve this by 2050. We need to leave the ability to adapt to whatever the best technologies are that come along in the next few decades.
The researchers frame the solution to the energy transition problem as the identification of one near-term investment strategy that is flexible across a wide range of possible future costs, followed by many alternative investment plans, each of which responds to realized future costs to meet the emissions reduction target.
If we think about investments in two stages, a near-term strategy and a long-term strategy, that creates flexibility to meet the long-term climate goal. We need that flexibility to make our grids more sustainable because we just don't know now what the future is going to bring in terms of technology, costs, and capabilities.
What we do in the next 10 years is critical because some options limit our long-term approach. For example, if we heavily reduce our dependence on natural gas and carbon sequestration becomes far cheaper than renewable energy and battery storage technology, that will drive up energy costs. Worse, poor decisions could lead to a greater use of fossil fuels to curb those costs or stabilize the power grid. By computing a large number of future scenarios using historical data researchers found natural gas played the most important role in near-term strategies. Importantly, the best short-term approach wasn't always the best long-term strategy. That's because those scenarios didn't allow for the most agile long-term plan. In their research, three dominant long-term scenarios emerged to meet both electrical demand and emissions limits. One relied on new natural gas with carbon capture, wind, and solar. Another consisted of primarily new wind, solar, and energy storage with very little new natural gas or nuclear energy. A third consisted of primarily new nuclear and solar energies. Which scenario will turn out to be the best future decision will depend on a lot of factors, including cost and technological capability. But society needs to be ready to implement any one of the three to meet the sustainability goals. Working backwards, researchers keyed in on short-term decisions that meshed best with the long-term strategy. That's critical, researchers said, because several of the near-term strategies didn't accommodate the long-term strategies at all. One effective short-term strategy relied heavily on new wind generation, followed by increases in solar energy, followed by natural gas, some with carbon sequestration and some without. That approach allowed for the lowest future energy costs and agility for long-term energy strategies when those technologies and costs are known.
We know the long-term goal, but pretending that we know exactly how we're going to meet some long-term emission targets just isn't realistic.
Instead, what we need to do is focus on what we know now and make decisions that can allow us to adapt as we realize what the future is going to look like.
Look around.
Sorry about that. So there are, of course, a wealth of non-climate related problems that our faculty and students are investigating. And one of those areas is a real focus on natural hazards, volcanic eruptions, earthquakes, flooding, and landslides. I myself have kept some of my research going, even as dean, and one of those areas has been work in the Florida Keys, looking at how wastewater disposal might be affecting nearshore water quality and the highly valued coral reef system offshore. My students and I have installed and analyzed samples from monitoring wells on a cross-island transect that is centered on a wastewater injection plant on the island, the city of Marathon in the Florida Keys. What we've been finding is that the wastewater is being injected at depth, but the wastewater is actually buoyant relative to the saline groundwater that surrounds it. And so it rises to the surface and then moves laterally out toward the coastline, which is bad, of course. But along the way, there's dilution, but there's also uptake and conversion of the wastewater components. And in particular here, we're looking at phosphate and nitrate, two key nutrients for organisms and sources of eutrophication in coastal waters. So what we're finding, unfortunately, is that this shallow injection, typically between 60 and 90 feet, isn't 100% effective in eliminating wastewater discharge into coastal waters and is likely leading to some eutrophication of those waters. And as a result of that work, the Florida Keys is moving aggressively, and in particular in Marathon now, toward very deep injection where they can minimize the effect of wastewater disposal on the coastal zone. Our college is also looking at other environmental issues, and this is one that I wanted to really emphasize here. We're looking at the issue of acid mine drainage, and this is one of the legacies of those extractive industries, in particular coal mining in the state of Pennsylvania. And we're looking at ways to treat that acid mine drainage, but importantly, also looking at the possibility that we can extract critical minerals from that acid mine drainage. We've gotten significant funding, and this is a picture of Sharma Pisapati, who's leading that effort. Support coming from the Department of Energy to build a pilot plant that's just now coming online And what we're demonstrating with that plant is that we can remove and separate uh, rare earth elements, cobalt, nickel, iron, and aluminum from the acid mine drainage while neutralizing the acidity and removing these toxic elements from the wastewater to the point where the Pennsylvania Department of Environmental Protection has permitted us to deliver our effluent from the plant directly into the sanitary sewer system as a non-toxic, acid-free, metal-free fluid. So we're working with industry partners now and state and federal government agencies along with partners across the state, other academic institutions, and across the country. This is a huge opportunity to scale this up, and especially for Pennsylvania, taking our land grant mission seriously here at Penn State and in the College of Earth Mineral Sciences. We're looking to advance this for the Commonwealth of PA. We think there are new industries that can develop. We'll be cleaning up the environment, and we'll be providing, contributing to national security with providing a domestic supply chain source for these critical minerals that are so necessary for modern technological development. So really a win-win-win. Just a couple other interesting things here. One is an example of some work that we're doing with the city of Pittsburgh to help them detect things like water main breaks. The approach here is to use buried fiber optic networks, those fiber optics that are delivering your internet phone services to you. Those those cables stretch with vibrations and so can listen to what's going on in the subsurface. They can detect water main leaks. We've used them to listen to the We Are Penn State at Beaver Stadium, so some fun applications. One that was initially sort of concerning here was we took a fiber optic network that runs across campus, and in particular down Pollock Avenue, and use that to image the subsurface. And what you're looking at here at the surface is the way in which that fiber optic cable runs. This stretch here is a stretch right down Pollock Avenue. And interestingly, what the researchers and the students detected was a significant cavity centered under the hub on campus. And long before the faculty member published this in a journal, he notified the Office of Physical Plant, who did a deep dive into the structural integrity. This is very deep down in the subsurface here, well over 300 feet, and a lot of good competent rock above it. And so not a threat to campus buildings, but just an indication of the sorts of things that we can learn when we think creatively about taking advantage of some existing infrastructure and turning it into a tool for scientific and engineering investigation. We also are looking to space and involved in various space missions, planetary missions. In this case, the sample return from asteroid Bennu. And so Penn State researchers were part of the team who received samples from this sampling mission that engaged with asteroid Bennu and returned material to Earth for analysis. And this is Kate Freeman in the middle here with students and postdocs. There's the recovered space probe, and then they're working with some of these samples. What they're looking for is to characterize organic material that's on the asteroid. This isn't, in this case, evidence for life on that asteroid. Organic material can be produced through non-biological methods, but it's important that we understand how that organic matter forms in space, and so we can differentiate signs of life with future sample returns from those that are just the result of non-biological processes. So I've been emphasizing all along that student engagement in our research is a really important part of what we do in the college and increasingly Penn State wide. We've always taken this approach. One of our former deans, Eric Barron, who became president of the university, really focused when he was dean of this college that we wanted to be the most student-centric college at Penn State. And one of the things that he started that we've continued and strengthened is a first-year student orientation program. We offer the entire incoming class an opportunity to arrive on campus and move in with our help early, and then go down to Lake Raystown for a few days of leadership training, bonding, getting to know one another, and getting to know other students and faculty and staff members in the college. We have a Ryan Family Student Center that Eric started that provides everything that our students need in terms of counseling, mentoring, and advising that help our departments in their quest for maximizing student success while at Penn State. And of course, getting our students out in the field where, we have many of our programs are field oriented, and that student engagement, getting students involved, international travel, these are all things that we prioritize and pride ourselves in terms of student engagement. So I thought I'd just return to this word cloud to remind you about the scope of what we do. I wanted to give you some contact information here, both for the college and for myself. I'm only 1 week left in the dean's chair, but one of the things I've really enjoyed as a department head and then dean is engaging with alumni. Such wonderful folks out there who support us in everything we do, support our graduates, and you support one another with that strong Penn State connection. And so I'm happy to continue being a part of that support network. So happy to answer any of your questions now or in the future, and then just encourage you to engage further with the college and with John Morrow, who will be my successor as dean. So thanks for your attention. I'm going to stop sharing now and look forward to being able to take a stab at answering any questions you might have.
Well, Ian, let me first of all say thanks again for both the presentation and kind of how you closed there. We offer these speaker series sessions to our alumni. We have so many Penn Staters who want to stay connected to the university, and obviously there are social reasons for that, and nostalgia, sports, you name it. But a lot of our alumni we know really want to stay connected to either the college that they graduated from or other parts of the university they have an interest in. They understand how much great and important research is being done here, and so for you to be able to share that and also have a willingness to kind of hear back from folks means a lot. So we appreciate that. We do have a number of questions that were submitted, and I'll kind of get through a mix of these here. Obviously, you talked a lot about climate change, so I'll get into that. One of our viewers asked for kind of a brief primer on climate change. Obviously, that's a big issue, but maybe sort of where things stand now, high level on research and on the changes that we're seeing in our climate globally.
Yeah, I mean, I think, one of the things that I might lead with there is just why I am so convinced about, carbon dioxide as a climate driver. And it's not really a belief. I'm a scientist. It's really my investigation of Earth history. I'm an Earth historian in most of what I do. I don't just work with wastewater and sewage. And what I find over and over again is that when there are events that have elevated the atmospheric CO2 content, the climate has warmed, it's gotten wetter, and depending on the magnitude and rate of that change, there's been, disruption to ecosystems. So, one of the things that I think we all acknowledge is that climate change is real. It's driven by the elevated CO2 in the atmosphere, which is a greenhouse gas, which warms the planet. These are all well-established facts, and that buildup of CO2 is a result of human activity. What we do going forward is now the important question. But I think that it's recognized here at Penn State and internationally from the scientific perspective that climate change is real and we need to do something about it. We need to reduce carbon emissions. We need to capture the carbon that we are emitting before it enters the atmosphere or even after it enters the atmosphere because of the greenhouse gas that's such an important factor. So right now, I think that science is pretty well established. We're interested in, for one thing, and one of the things we're doing at Penn State is trying to take kind of that global picture and zoom in on where it matters most at the regional scale. What is going to happen in the future at a regional scale, so we can work with communities, municipalities, states to better plan for that future. And so looking at impacts and also looking at technological development for things like carbon sequestration, as well as helping advance renewable energy.
Actually, another one here. This is an interesting question. I kind of like the phrasing here. One of our viewers asked, can you name one or two of the transferable skills gained during an education in the College of EMS? The person asking this is an alum and a physician and a world traveler.
Oh.
So, yeah, what would be some transferable skills you'd say from an EMS education?
It's such an important question too, and our curricula, our courses, and our expectations for ourselves and for our students have evolved with time to a real focus on skill development, not so much knowledge content, but skills. And one of the things that ties in with this out of the classroom experience engagement in research is developing our analytical reasoning skills. We want to be able to objectively, systematically evaluate evidence, look for trends in data, break down highly complex problems into testable components. And so, bringing our students through real world problems, having them help in the design of experiments, in the analysis of data, use of advanced tools for the analysis of that data, like artificial intelligence approaches, machine learning, and by the way, we are launching university-wide an expectation for base level literacy in artificial intelligence, and that's going to involve online training for everyone, faculty, staff, and students, that will form the basis for more advanced pursuits, for the staff to use more advanced tools in their work, for the faculty in their teaching and in their research, and for our students in learning. So I think that analytical reasoning, some literacy around data analysis and artificial intelligence. Our students learn how to think about systems because we really focus on the interactions among components of the Earth system, of the human engagement with Earth systems. So systems thinking is what some of that one of those other transferable skills. They get some exposure to and practice with project management, although I do think this is an area, and it's in our strategic planning to flesh that out. Some business acumen, I think, is useful, and then communication skills, and with that, teamwork are things that we really emphasize. So those transferable skills really are important because more now than ever before, students are going to there are going to be changes in their career direction and what they're doing, and what's going to be important are those transferable skills. And I think the person who asked this question is a great example of that. When I go out and meet alumni, I don't meet petroleum engineers who are still mostly doing petroleum engineering, or geologists who are working on geologic resources. Often they've moved into leadership roles, CEOs of companies where that business acumen can prove really important. And we're trying to build that into the curriculum so that there's a business and finance component for all of our graduates, not just our energy graduates.
Uh, Thank you, Lee, for that one. And the next question sort of touches a bit on the same theme, but as we both know, obviously Penn State is a place that really prides itself on interdisciplinary research and collaboration. So a question that kind of touches on that, what interaction in particular does EMS have with the College of Health and Human Development and or the HRIM program?
Yeah. Well, it's interesting because, at face value, you'd think, what interactions could we have with health and human development? We have actually deep connections with HHD. One example of that, and something that's very important at Penn State, given at least at University Park, given where the campus is spousal hiring. And we've had a number of cases where faculty spouses have come in, either into HHD, where the spouse has stronger connections to EMS or vice versa, and we've partnered in those cases. And one of those cases is a spouse who's a geographer but who studies health disparities, and so is growing collaborations, not just continued collaborations with their spouse in HHD, but with other faculty and students in health and human development. One of the other areas, specific areas that we work closely with HHD on is in the general area of sustainability. Health and human development is the home of the sustainability leadership minor, which is an undergraduate minor, and sustainability has been a major theme over here in EMS. And so we work closely, initially through that minor with courses and faculty collaboration, students participating in the minor, but we're talking about growing sustainability efforts at Penn State, and that will involve, other units as well, other colleges and campuses, but with a strong collaboration with HHD. So thanks for that. Thanks for that question.
I'll put you on the spot here a little bit with a question that we got in a couple variations. The impact of politics on higher education and on science in particular. It's been in the news a lot in recent years, I think. Can you speak at all to what Penn State has done to sort of make sure that the scientific integrity of the work is being done is maintained, maybe in the face of that?
Yeah, I mean, it's been challenging. It's been challenging for academia for the last few years, and in particular in research. We have in our college have a lot of funding that comes from National Science Foundation, and this year the funding rollout has been particularly slow, and a much stronger emphasis than ever before on alignment of federally funded programs with the administration's priorities. And frankly, that's been a challenging for our work in climate change, because climate change research is not a current administrative priority. And so that's been a bit of a problem. We've had slowdowns. We've been fortunately able to provide bridge funding, and that is largely the result of the substantial endowment. That's thanks to folks like you folks who are viewing today, helping to support programs and students at Penn State, support for faculty. Even my dean's chair has been utilized to provide some bridge support, for example, for graduate students who are in the midst of their master's or PhD programs, but for which the funding has been terminated or slow to be realized. So there's no doubt there's been impacts there. But like I said, we have a balanced portfolio in this college, and are really well positioned with this new strong emphasis on critical minerals and growing secure supply chains for those materials and the products that they're used for. And so even within this college, and then we extend across Penn State, everything from the geology and the mining of the extraction of critical minerals from waste, coal waste and acid mine drainage, to the processing of that material, concentration of it in the conversion of it into metals, the production of magnets. These are all things that we're working on, and these are areas like the exploration of space and the planets that seem to be pretty administration proof. Strong support that spans from one administration to the next, and so those areas are currently growing. So there have been challenges in areas that aren't so well aligned with the president's priorities, President Trump's priorities, and other areas that I have been well supported and are advancing. We get good support from Office of Senior Vice President for research. There's some advocacy going on to try to ensure we have good support from our congressional delegation and from Congress in general is supporting science, and it's just a little bit slow to get that through Office of Management and Budget to the agencies and out to our researchers.
Thank you, Lee. I think we've got time maybe for two or three more. There are two that have popped up in the chat here. This question is, have you ever considered involving environmental psychologists in helping to teach climate change to folks who maybe don't have the higher education opportunities that our students have?
Yeah. Well, it's a great suggestion. I've had some engagement just in terms of the general questions of how to communicate climate change science, how to engage with folks who don't necessarily aren't inclined to, the standard approach, standard pedagogy kind of professorial approach to engaging in those discussions. But we haven't done anything to my knowledge formally in that regard to help understand, what resonates, where biases might exist, how we might, how we may be conveying a biased opinion ourselves. And so I really like that suggestion. And look, if the person who asked that question or anyone else has any suggestions along those lines, please do reach out. I'd love to follow up on that. One of the things I'm going to be doing here, I have a leave of absence coming up, and sort of a sabbatical, and I really want to redo some of the books that I've put out with in terms of climate change and Earth systems, and maybe thinking through with somebody who understands the psychology of communicating environmental science could make those books more effective. So please do reach out.
One more from the chat here. Is the college doing any work on carbon-free reduction of iron ore to metallic iron?
Yes. And in our Department of Energy and Mineral Engineering, we're looking at other processes for that reduction. And so the issue here is in that carbon reduction of metals like iron. Since you're using carbon as the reducing agent, what you're producing is oxidized carbon. That's carbon dioxide. So you're looking to reduce emissions, if I understand the question correctly. And so we are looking at electrodes, carbon-free electrodes, or electrodes that don't, that are carbon-based but don't emit CO2. And so if there's follow-up there, again, I'm lkump@psu.edu. I can put you in touch with the department and with the researcher Randy Vanderwall, who's working in that particular area, looking at that, very important step, because all of these metals that I've been talking about that we're extracting from acid mine drainage, for example, come out as metal oxides. And so they're oxidized. They need to be reduced to a metal that can be used for the intended manufacturing purpose. And if we do that in a typical way using reduced carbon, then we are generating CO2 in the process. So looking for ways that we can do that without producing CO2 is an important research area. And there is work being done. I'd be happy to connect you with the person doing that work, one of the people.
Thanks for that, Lee. One more for you here, and we won't get to all of them today. We had a lot of great questions, but mindful of time. But I have a question asking, as you reflect on your time as dean and the few decades you've spent in the college and the faculty, what can you point to as something that you're most proud of?
Huh. Well, I beginning with my time as department head and then as dean, um, I really have felt that I'm a facilitator and a matchmaker. So, for example, I read all the faculty activity summaries in our college because I can do that. Some of my, colleagues, the dean of science, the dean of engineering, couldn't do that. There are just too many of them, but at scale, I can do that. And I'm not looking to evaluate the faculty. That's what's done by their committees and department heads. But looking for common areas of interest and collaboration. And I've used my resources to then grow that collaboration. And those resources might be to fund a graduate student or to fund a group of undergraduates or a postdoc to work on that collaboration, to bring people into some new areas to keep the vigor of their research alive. And so I think it's sort of the sum of those matchmaking activities that I think maybe has been my my biggest impact. At first in my career, I thought it was going to be the students I've interacted with through my classes and my own research, and I'm proud of successes and impact along that way. But I think from the perspective of what is unique about our college, this really interdisciplinary focus, I think the efforts I've made to bring people together to form teams to solve some important problems for society, and including areas like critical minerals, which was not a main focus in our college when I started. There are a couple people working on that. I supported them, brought in a bigger team, kept some programs going during challenging times, and now we are well positioned to be a major player internationally in responding to that important problem. So, I don't like to think about my own successes, so I don't catalog them. But I do have always felt like my role is to facilitate others' success of students, and then of other faculty now as an administrator. And I think I've had some impact that way.
Well, thank you, Lee. Yeah, I think, no doubt. Again, I've been around here 20 years now. I've been familiar with your name, obviously, throughout that time. And I think your reputation and the reputation of the college kind of speaks for itself. So, job well done there on one of our, like you said, not the biggest college here, but one with a ton of history and huge impact in a lot of really important areas. So, I hope you take pride in your role in all of that. I want to thank you again, Lee, for joining us today. And I want to thank everybody who joined the session as we wrap up. Reminder, folks can view a full listing of all our events at alumni.psu.edu/events. You can find upcoming speaker series and other information, including recordings of this and others that we've done in the past. So again, Lee, thank you so much for your time, and thanks to everyone who tuned in today. We are
Penn State. Thank you.